In the last video, we discussed the overall system architecture. In this one, we're going to be discussing the machine learning pipeline architecture. Our banking API is going to integrate a machine learning pipeline designed to detect fraudulent transactions in real time. This pipeline will replace a rule-based approach that we shall also implement so that we have an adaptive and data-driven solution that continuously improves over time. Let me walk you through the components and the flow. First, we're going to have the data collection and processing. Our pipeline begins with collecting transaction, user, and account data. The transaction data is going to be the raw transaction information, including amounts, timestamps, types, etc. The user data is going to include the customer profile information, transaction history, and behavioral patterns. And then the account history is going to be historical account activities such as balance changes and usage patterns. Then the data collected is going to be fed to a feature extractor. This is going to be the central component that processes raw data and extracts meaningful features. Then the extracted data from the previous step is going to be processed through feature engineering so that we can extract meaningful patterns. These patterns are going to include time features, which basically extracts time-based patterns such as the hour of the day of the week, etc. that may indicate suspicious activity. Then the metadata features, this is going to extract information from transaction metadata such as currency, conversion rates, etc. Then we have the account features. These are features related to the account age, balance, and status. Then we have the user history features. These are patterns from the user's previous transaction behavior. And then we're going to have the velocity features. These are going to be features tracking transaction frequency and volume over different time windows. Then all these features are going to be piped through a data preparation service. This service is going to combine all the features into a clean dataset ready for model training. So you can proceed to the model training part. The features that we have extracted are going to be used to train a gradient boosting classifier. We shall be using gradient boosting as it's the classifier for the fraud detection system that we are building. In our model training, we're going to first train or test split. This is the process of dividing the data into training and testing sets. Then you're going to pass the data to the model trainer, and the model trainer is going to orchestrate the training process. Then you're going to pass the data through the gradient boosting classifier. This is going to be the core machine learning algorithm that we're going to be using for the fraud detection. Through this model, we shall identify which features are most significant for prediction. That's why we have this feature importance part. And then we're also going to have the output of a trained model. This is going to be the output model that is ready for evaluation. Then move to the model evaluation stage. In the model evaluation stage, the trained model is going to be evaluated using multiple metrics to assess performance. The metrics are going to be 1, the AUC score, which is the area under the ROC curve, which is a key metric for fraud detection models. Then precision. Precision is going to measure the accuracy of positive predictions. Then we have recall, which is going to measure the ability to find all the fraud cases. Then we're going to have the F1 score, which is going to be the harmonic mean of precision and recall, these two. Then you're going to have the confusion matrix. This is going to be a table showing true positives or false positives, etc. Then we're going to compare the different models or versions to select the best one. And now we can move to the model deployment. So at this stage here, the best model is selected and deployed to production. We're going to choose the highest performing model based on the evaluation metrics that we've just discussed up above. Then that is going to be piped through the model deployer. This is going to handle the deployment process. Then we're going to have a model registry. This is going to be the central repository for storing and versioning our models. And then we're going to have the production deployment, which is going to be the process of making the model available for real-time inference. So we can move to the inference part, which is just right up here. So in this part here, we're going to infer the model performance and also perform a risk analysis. So we're first going to have this new transaction, which is going to be the real-time transaction data requiring fraud analysis. Then it's going to be piped through the model inference, where we're going to use the deployed model to make predictions. Then we're going to go through a risk analysis stage, where we're going to analyze the model's output to determine the risk level. Then we're going to assign a risk score, which is a numerical score indicating fraud probability. Then we're going to flag or clear the transaction. Here, a decision is going to be made whether to flag suspicious transactions or to clear legitimate ones. Then, as with any machine learning model, we have to have a human involvement. So in our case, we're going to also have a human review stage. where transactions with high risk scores are going to be flagged for human review. The human reviewers are going to either confirm or reject the fraud flag, providing feedback. This feedback, along with new data, is going to be used to retrain the models periodically. In our case here, the human reviewer is going to be an account executive who is going to be reviewing the flagged transactions. Then this reviewer can either confirm or reject the fraud. Then you're going to have a feedback loop where we capture the human decisions for the model improvement. Then we can auto retrain our data, where we schedule processes to retrain models with the new data. And we're also going to be integrating machine learning flow, which is somewhere down here. And the MLflow is basically an open source platform for managing the end-to-end machine learning lifecycle. In our fraud detection system, MLflow is going to integrate with our pipeline to record training parameters, track model performance metrics, store model versions, and manage deployments, therefore creating a complete audit trail for the machine learning process while simplifying the model management. Our MLflow is going to have an MLflow tracking server, which is going to be the tool for experiment tracking, model versioning, and deployment, and it's going to connect to the various pipeline components to log metrics, parameters, and artifacts. And that's basically it for our machine learning flow. I hope it makes sense. If not, don't worry, we're going to be working on this step by step as we build our API. And that's it for the machine learning pipeline architecture. I'll see you in the next lecture.